Okay, in this video, we're going to take notes on all the different properties of a parallelogram. Last week and beginning of this week, we reviewed all the different definitions of all the quadrilaterals that we could have. Specifically, in this video, we're going to focus on parallelograms. If you remember, we have three special quadrilaterals: trapezoids, kites, and parallelograms. And then within the parallelogram family, we have special types of parallelograms. So we will get to those special types of parallelograms, but for today, we're mainly going to focus on what is special about a parallelogram. So we started out with the definition of a parallelogram. It is a quadrilateral with two pairs of opposite sides parallel. So anytime they give us a quadrilateral with two pairs of opposite sides parallel, we automatically know it's a parallelogram. And knowing it's a parallelogram, as you're going to discover today, is going to tell us more information about that figure. So let's start with our first property of parallelograms. If you remember when we were doing coordinate plane problems, we also found something special about the opposite sides because we had to find the length and we had to mark things congruent. And if you recall, we found that opposite sides are congruent. Now, your note sheet says both pairs of opposite sides. That's very important. It's got to be both pairs of opposite sides. So if I were told I had a parallelogram, I'd go ahead and mark those congruent to each other. We're going to do some example problems in a minute where we have algebra problems and we have to set those up and try to find certain values. The second special property is that opposite angles are congruent. So the angles that are directly across from each other are going to be congruent to each other. And when we look at the next property, we're going to examine why that is. So let's move on to property 3, which says that consecutive angles are supplementary. Which means, if you remember, that they add to 180. So, and the reason for that is if those sides are parallel, that's one pair of opposite sides parallel, that means this angle and this angle are supplementary because they're consecutive interior angles. So if this one is 70, that one has to be 110. But we also know those are parallel, which means if this is 110, this one is 70 because those are also consecutive interior. And then this fourth angle has to be 110 for the same reason. Now look at your opposite angles. You notice that they are definitely congruent, and it's for that reason, all those consecutive interior angles being supplementary, that makes the opposite angles congruent. So then our property 4 is going to deal with the diagonals. They will always bisect each other. What that means is they cross at the midpoint of each diagonal, which means these two pieces are the same and these two pieces are the same, which means that point right there is the midpoint of each diagonal. It cuts it in half. So now let's do some practice problems. I'm going to do some examples and then I'm going to ask you to pause the video so you can try some, and then y'all can replay. You can start the video again and check your answers. The first problem we have has some angle markings inside. So the first thing I'm going to do is mark my angles that are congruent to each other. That one and that one are across from each other. And that one are across from each other. So what can I just look at my picture and automatically know that are the same? The blue angles are opposite angles, so they're congruent. Anytime two things are congruent, we can set them equal to each other. And this problem is very straightforward because we have no algebraic expressions to solve for. So then if I look at the greens, I can't do that because there's nothing in this bottom right corner. There's no measure, there's no variable or anything. But what do I know about these two angles? Well, they are supplementary because consecutive angles are supplementary, which means if I add those together, I get 180 degrees. So then if I subtract 75 on both sides, I'm going to get 105 degrees for y. So pause the video and see if you can attempt number 2. Once everybody feels like they've given it a shot, you can start the video again and we'll check it. Okay, in this problem, I'm going to do the same thing again. I'm going to mark my angles congruent that are across from each other. These two are congruent, which means I just set those equal to each other and solve for x. I minus x on both sides, I add 3, and I get 40 for x. Let's look at problem 3. We've got another example. You guys should know how to do this one. So let's pause it again, and let's see if you could do this one, and then start it again once most everyone is finished. Okay, these two are right next to each other, so they are consecutive, which means they add to get 180. So I'm going to combine like terms on the left, divide both sides by 3, and I get 60 for y. Okay, let's look at 4. I'm not sure if you got that one in a minute ago. If you want to pause it again, try this one, and then we can check. Okay, in 4, I'm going to mark my angles that are the same. These two are across from each other, so I'm going to set those equal to each other. Combine like terms, and I get A is 20. And then I'm going to need to use A to help me to get B. Now those two are consecutive, so they're supplementary, which means I add them together to get 180. Before I do that though, I'm going to substitute A back in to find what that angle measure is, which means I'm going to substitute A for 20. 4 times 20 is 80, minus 15 gives me 65 degrees. So what that means is if I add 65 and B, I get 180. So B has to be 115 degrees. Okay, let's look at number 5. Now, we're not looking at angles in this one. We're looking at actual side measures. What do I know about the opposite sides in a parallelogram? Well, they are congruent. Anytime two things are congruent, I can set them equal to each other. So I'm going to write 2 equations, setting them equal to each other. Now, sometimes, just like on the ones we did before, you're going to have to use one variable to get the other variable. So I would go ahead and write your 2 equations and then see which one you can actually solve for first. So here, I can go ahead and fill that in. I don't have to solve for anything for y. This equation, I'm going to minus x on both sides, and I got x to be 5. So again, let's pause the video, and you guys try number 6. Okay, I'm going to mark my sides congruent. I'm going to write my 2 equations. Now, if I look at the first equation, I have a y and I have an x. I can't solve for one variable there. So I'm going to go to my second equation, and notice you only have x's. So I'm going to get my x's together by subtracting x. Then I'm going to add 5 to both sides, and then I divide both sides by 2, and x is 7. So where I have x in the other equation, I'm just going to substitute. So y minus 2 has to equal 8. Y must be 10. Okay, my next 2 examples, I'm going to be looking at the measures of the diagonals. Think about what our rule was for diagonals. The diagonals are going to bisect each other. which means they're congruent. So anytime two things are congruent, I may set them equal to each other. So we had no algebra to do in this one. We can just put our values here. So pause the video, please. Work number 8, and then let's start playing again. I'm going to set my diagonals congruent to each other, which means I have to set them equal to each other. Let's solve for A first. And then where I have A in the other equation, I'm going to use it to help me solve for B. Now, you can either substitute here, or you could have gone over here and substituted in the picture. So maybe it's a little easier for you to see that you're going to set those two things equal to each other. Whichever way makes more sense to you. So let's look at our last 2 example problems. I'm going to do 9 with you, and then I want you to pause it, try 10, and then check your work. So we've got a whole lot of angles here. We have some diagonals, but we don't have any diagonal measures. So right now I'm not going to worry about marking those congruent to each other. I could, but it's not going to make a difference in helping me solve for my different angles. What I'm going to have to use are the fact that I have parallel lines, which means I have alternate interior angles. I'm also going to use vertical angles. I'm also going to use some linear pairs. All these are terms that we used last semester. So let's start with the vertical angles. I'm going to go through and mark anything I can in the picture. I know that's 110 because these two are vertical. I could find Y because those two, this one and this one, you should recognize as being a linear pair, which means if I add those together, I get 180, which means Y, if I subtract 110 on both sides, has to be 70 degrees. So I'm going to go ahead and fill those in. Then I need to try to figure out how I can get X and Z. Well, this one and this one are congruent because they're alternate interior angles. So X has to be 20 degrees. If I think about that same concept, this one and this one have to be the same because those are alternate interior. So that has to be the same as whatever Z is. Well, if you look in here, you should be asking yourself, what is that? It is a triangle. And what are the sum of the interior angles of a triangle have to add to get 180? So I'm going to take 40 plus 70 plus whatever Z is. It's got to equal 180. So if I subtract 40 and 70 on both sides, then I am going to get 70 degrees. Now, that's just sort of random that those both ended up being the same. That's not always going to be the case. So pause your video, and you guys try number 10, and then we'll replay once you think you have it. Okay, in number 10, I'm going to go ahead and mark everything congruent if I can find any particular things that need to be congruent. Looks like so far the alternate interior angles, that's the first one I can see, is that A has to be 25 degrees. Okay, I know also actually that these two are the same, so this has to be the same as B. And I can see that this is a triangle, which means that B plus 45 plus 40 has to equal 180, which means B has to be, if I do my math correctly, 95 degrees. So that leaves me with C. So I want to think about how could I find C? If we look at, I'm going to go and erase some of my markings just so it's a little cleaned up. I could find that angle right there because it is a linear pair with this, which means that 45 plus whatever this angle is right here has to equal 180. So that angle is going to be 135. And then again, I have a triangle where 25 plus 135 plus C has to equal 180. So that means C has to be 20 degrees. Okay, so that wraps up the notes for this. You've got a practice worksheet to work on after this, and then you're going to have some more practice tomorrow. And then you have notes tomorrow night over the next section, which is 6.3, where we sort of flip these rules around. So homework tonight is 6E. Homework tomorrow night is going to be video notes.